In the global carbon cycle, carbon is cycled through Earth's organisms, the soil, the atmosphere, and the oceans. Most of Earth's carbon is found in fossil fuels and in carbon-containing minerals and rocks. In contrast, the atmosphere contains relatively little carbon, and it is in the form of carbon dioxide and methane. The quantities of carbon that are held in or exchanged annually by the ecosystem compartments are expressed in units of 10 to the 15th grams. On land, most of the carbon available to organisms is stored in soils. During cellular respiration, soil organisms and other terrestrial biota release carbon in the form of carbon dioxide to the atmosphere. The opposite happens during photosynthesis, when plants take carbon dioxide from the atmosphere, indicated here as GPP, for gross primary production. Carbon dioxide is also rapidly exchanged between the atmosphere and the surface waters of the oceans. The rate at which carbon dioxide dissolves in the ocean slightly exceeds the rate at which it outgasses for two reasons. First, some of the dissolved carbon dioxide is converted into organic compounds by phytoplankton, such as diatoms. Most of this carbon is then recycled in surface and deeper waters through the trophic interactions of aquatic organisms, but gravity moves a steady rain of organic detritus into the benthic zone. Second, some of the carbon dioxide is transformed through chemical reactions with water and other dissolved elements into relatively insoluble carbonate compounds, especially calcium carbonate, which ultimately also sink to the bottom. When dissolved carbon dioxide is converted into other compounds, the ocean is more likely to take up additional carbon dioxide from the atmosphere. Despite the fact that the ocean absorbs more carbon dioxide than it releases, atmospheric carbon dioxide measurements from on top of Mauna Loa, Hawaii, show an upward trend in carbon dioxide concentrations over the decades, with a current high exceeding 380 parts per million. Before the Industrial Revolution, the concentration of atmospheric carbon dioxide was probably about 265 parts per million. The zigzag pattern reflects the seasons. During the Northern Hemisphere winter, metabolism exceeds photosynthesis, resulting in a net release of carbon dioxide in the atmosphere. In the summer, photosynthesis exceeds metabolism, and relatively more carbon dioxide is taken up by plants. Carbon dioxide is considered a greenhouse gas. It is transparent to visible light, which warms the surface of the Earth. The warmed surface emits infrared radiation back toward space, but this wavelength is absorbed by carbon dioxide and other greenhouse gases, which then heat up and re-emit infrared radiation, trapping the energy and heat at Earth's surface. Increasing concentrations of carbon dioxide in the atmosphere are implicated in global warming. Human activities influence the carbon cycle in a number of ways. Deforestation, changes in land use, and the burning of fossil fuels increase the atmospheric pool of carbon dioxide. The carbon released from burning fossil fuels comes from plants that lived hundreds of millions of years ago, such as those in a carboniferous forest, which transformed into coal, and oceanic plankton, which transformed into petroleum and natural gas. The atmospheric pool of methane is increased through livestock production, rice cultivation, and water storage in reservoirs, because microbes in the guts of cattle and in waterlogged sediments break down organic compounds anaerobically to produce methane. Although the atmospheric pool of methane is far smaller than that of carbon dioxide, both are potent greenhouse gases and affect Earth's radiation balance.